Hello, welcome to UVA's electromagnetic fields video series. In this video, we are covering problem number 33 of transmission lines from fundamentals of applied electromagnetics. And in this problem, the problem is asking two half-wave dipole antennas, each with an impedance of 75 ohms, are connected in parallel through a pair of transmission lines, and the combination is connected to a feed transmission line, shown as in figure P2.33. All lines are 50 ohm and lossless. Part A is asking calculate ZN1, the input impedance of antenna terminated line at the parallel juncture. So what's happening is we have two antennas in here, and here. So what are we trying to do in part 1 is calculate ZN1, and in part B of the question we are adding the input impedance of both antennas, so ZL will be the parallel combination of Z1N and Z2N. And finally, in part 3, we'll find the total Zn looking into the whole transmission line circuit. So let's start doing it. So in part A, the L1 is given as 0.2 lambda. ZL is given 75 ohms. And also the characteristic impedance for the whole circuit is given 50 ohms, since it's a lossless transmission line. So when we calculate this using the input impedance formula, Zn1 equals to Z0 times ZL plus J Z0 tangent of beta L over Z0 plus J ZL tangent of beta L, which in here beta is defined as 2 pi over lambda. So when we plug in the given parameters, Zn equals to 50 times 75 plus J 50 tangent of 2 pi over lambda, and the L in here is L1, so the L1 is given as 0.2 lambda. It's actually given in the problem in here and here for Zn and Z2. We need to notice that L3 is different than these with lengths. Okay, so let's plug in the parameters in the denominator too. So 50 ohms plus J, this is ZL, which is 75 ohms, times tangent of 2 pi over lambda times 0.2 lambda. So when we multiply everything, so this one and this one cancels, this one and this one cancels, and inside the tangent we will have 0.4 pi, and the numerator too, 0.4 pi. So using the calculator, when you calculate the tangent of 0.4 pi, we will get 75 ohm times J 50, and the tangent of 0.45 is 3.078. Plug in the same thing in the denominator too, 0.78. So Zn1 equals to, actually I'm sorry, these are all Zn1s. Yeah. Zn1 equals to, when you evaluate all the numbers, Zn1 equals to 35.2 minus J 8.62 ohms. So this is Zn1. In part B of the question, it says combine Zn1 and Zn2 in parallel to obtain ZL prime, which is the parallel combination of Zn1 and Zn2. And we'll see how does it look like. So when we look at it, since the load at antenna 1 and antenna 2, they're same, and the length of the transmission line is the same, so the input impedance is going to be the same. So what I mean is Zn2 will equal to Zn1. They will be the same, they will have the same values. So to combine them in parallel, we can simply use the simple formula from our previous classes. So Zn1 equals to Zn2, and when we connect them in parallel, ZL prime equals to Zn1 times Zn2 over Zn1 plus Zn2. We can literally take reciprocal of each impedance and calculate that way too, but this way is easier. So when we do that, since Zn1 and Zn2 are same, we can say Zn1 squared over 2 times Zn1. Cancel this with this one. So we will have ZL prime equals to Zn1 over 2. We already had the Zn1 calculated in here. So when we plug in 35.2 minus J 8.62 over 2 ohms, ZL will be equals to 17.6 minus J 4.31 ohms. So this is the parallel combination of Zn1 and Zn2. Now in part C, it's asking calculate the whole Zn looking into circuit. So this Zn, when you look at the circuit from this point, what's the input impedance? How does the input impedance look like? So we need to take into account that the transmission length is different in here. It is 0.3 lambda. So let's calculate part C. So in part C, using the same formula, Zn equals to characteristic impedance times the parallel combination, since now our load is the parallel combination of antenna 1 and antenna 2, plus J Z omega times tangent of beta L. Beta is the same, it's 2 pi over lambda, but L is different this time. And in denominator we have Z naught plus J times ZL tangent of BL. L is given as 0.3 lambda, as I said before. So when we plug in all the numbers 50 times, we just calculated ZL as 17.6 minus J 4.31 plus J Z naught is 50 ohms times tangent. I'm sorry, in here the beta is 2 pi over lambda, L is given 0.3 lambda, over Z naught is 50 ohms plus J times 17.6 minus J 4.31 times tangent over 2 pi over lambda times 0.3 lambda. Now this looks like a lot of math. You can literally calculate it, or you can simply plug it in Wolfram Alpha or any online calculator, and it'll make your life much easier. But you can actually calculate it. So when you multiply j by j, it will be -1, and also you plug in the values of tangent by using a calculator as well. So when you calculate this equation, Zn equals to 107.57 minus J 56.7 ohms. So this is the input impedance looking into the whole circuit from here. This is how it looks like. All right, thank you.